And here brings us to scenario D, our final scenario. We have an observer who is standing on a hill viewing two buildings. Using the two buildings and the observer, we are again able to construct our triangle. Where we have the two buildings we will call A and B, and our observer which we will call N. Now we know the distances between our 3 points. We know that the two buildings lie 6 miles apart. We know the observer to one of the buildings is 3.2 miles, and the observer to the other building is 4.8 miles. Does not matter which of the two sides, distances to the two buildings, you label which. The scenario will work either way. Now when we look here, we can see that we have all three sides, but we do not have any of the angles at this time. With three sides, we have side, 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 which is law of cosines. We'll be doing the law of cosines for this one. This one's a little more difficult. You have to be careful. Since we are here looking for angle N, so we're going to let the measure of angle N be the angle measure between the observers lines of sight to the buildings. Now, as we are looking for an angle, it's very important we set up the equation correctly, law of cosines. So doing that, we will need our missing angle is angle N. So that will be also our side on the one side. So it'll be N squared is equal to A squared plus B squared minus 2AB cosine N. It's very important that the side by itself matches the angle in which we are solving for. So using that information, we now know that it will be 6 squared is equal to 3.2 squared plus 4.8 squared minus 2 times 3.2 times 4.8 times the cosine of N. Now, simplifying, we get 36 is equal to 10.24 plus 23.04 minus 30.72 cosine N. All we did here was simplify the three values that are squared and the product of the coefficients to the cosine. Continuing that, we were able to combine the two constants on the right hand side. So we now have 36 is equal to 33.28 minus 30.72 times the cosine of N. Again, since we are trying to get the cosine of N by itself, we'll treat this like a two-step equation. We will move 33.28 by subtracting it to both sides, giving us 2.72 is equal to negative 30.72 cosine N. Again, still working to get the cosine of N by itself. We'll divide its coefficient, the negative 30.72. Very important you do not lose this negative because it will change, have a drastic impact on the solution. So the constants on the left right-hand side canceling out, leaving us the cosine of N is equal to approximately negative 0.0885. Now just to have some room, we're going to go ahead and move this up. And we'll look at it from up here. So we have the cosine of N is equal to negative 0.0885 0.885. Now, in order to get n by itself, we have to clear the cosine, which we'll use an inverse ratio. In this case, arc cosine. We'll take the arc cosine of both sides, leaving us the measure of angle n, and the arc cosine of a negative 0.0885 is 95.1 degrees. So to answer in the scenario of the question, the angle measure between the observers lines of sight, because we are between two of them, is 95.1 degrees. And there we, ladies and gentlemen, have the 4 scenarios on using the law of sines and cosines to solve a real-world scenario.